It comes up from down low in the third quadrant. And I don't know why this word is what comes to my mind every time I draw this little graph, but squiggle is the word that comes to my mind. It like squiggles through the origin, okay? Makes that little curve, like squiggle through the origin. So in this class, okay, you know, I probably will refer to this kind of a shape as a squiggly, okay? This is not a mathematical term you'll find in any math textbook, but when you hear me use that word, you're going to picture a graph that looks like this, okay? It comes up and then does that little squiggle somewhere. Now, the parent squiggles through the origin, but other squigglies might be squiggling someplace else, okay? Now, one thing I want you to understand, okay, if you look at the graph here, watch me point, okay? See this piece of the graph right here? This part of the graph is not parallel to the y-axis, okay? Well, if it's not, you might say, well, what is it doing? It's what? It's coming out further and further. Slowly, it's coming out, but it's not just going straight down. And the same thing at the top here. This part of the curve is not parallel to the y-axis. It's continually not just going up, but it's going to the right. So I want you to understand that. Now, I will admit sometimes when I draw it, and I know when you draw them, it may look like one of those pieces is parallel. It's okay. I'm not going to have a fit if that happens, okay? But try not to make it look too parallel to the y-axis, because it's really not supposed to be. Okay, number 3 family that we're going to study is called the quartic family. Quartic. The graph, well, let me give you the equation first. The equation, the parent equation in this family is y equals x to the 4th power. 4th power. Excuse me. That's the parent. Say again?
There's not one of those in the book.
I know, they don't have one of those, but I'm including these. Okay? And I will tell you why I'm going to include them. Because the shape of this parent is like a parabola. It is very similar to a parabola shape. I would describe it personally as a little bit flatter at the bottom than the y equal x squared graph, so that when I try to draw it for you, it's got a little bit more flatness down here, but it still has that basic parabola shape. So if we can work with the quadratic equations, there shouldn't be any reason we can't work with the quartic equations. They're going to have a similar graph. And what I can do is show you, well, actually you can do it while you're waiting for me to pull it up here. If you've got your calculators with you, go ahead and try to graph y equals x squared and y equals x to the 4th power. Put both of those equations in your y equals screen. Make sure your window values are the friendly window values. Do you remember, if they're not, how you can get them to be the 10 and -10 numbers in the window screen? Anybody remember?
Good window.
Look at your window screen after you get your equations in. Okay. X squared, and on the second equation, we're going to go x to the 4th power. Okay, but before I press graph, I'm going to check my window screen. Mine has the friendly numbers. If it didn't, what would I press to get them? Anybody remember? Didn't we do that the other day? No? Zoom 6. Zoom 6, where it says standard. If you press zoom and then 6, your window values will automatically go. Now look at the graph. That's x squared, and the second one is x to the 4th. Now, the x to the 4th is this one. Look up at the picture for a minute there. The inside parabola is the x to the 4th. And maybe it's a little hard to tell here, but it's a little bit flatter at the bottom than the x squared, okay? What I can do is I can clear out x squared for just a second and just graph x to the 4th. Can you see right here how it looks a little flatter than the other one? And really, that to me is the only difference. I mean, I guess you also would say it's narrower. But they're so similar, and here's the deal. I know you might be sitting there thinking, geez, when we're doing problems, I got to distinguish between an x squared and an x to the 4th. I got to worry about making the x to the 4th equations look flatter and skinnier or narrower. You know, that's going to be a pain, you know. No, you're not, okay? You're not. The differences are very subtle. And so consequently, when we do our problems, we're not going to really concern ourselves that much. We're going to say, if I'm doing an x squared problem, I know the graph is a parabola. If I'm doing an x to the 4th problem, I know it's a parabola. And as long as I make it accurate as far as what she tells me, you know, I have to do, then it will be okay. So don't worry about that part, all right? Okay. I forgot which one we've got. Quadratic, cubic, quarter. Okay, this is number 4. And I know this one's not in your book either, but that's okay. It's going to be, it's called the quintic function. You ever heard of a mom having quintuplets? How many babies does a mother have if she has quintuplets? 5 of them. So the parent equation has to have an x to the, what, 5th power, exactly. And guess what it looks like? Anybody want to guess what the...
Like, the cube?
The cubic. The quintic, which is x to the, y equals x to the 5th, looks very similar to the cubic. Is there a difference? Well, of course there is a difference. I'm not going to tell you they're exactly the same, quintic and cubic, but I'm going to tell you that